This is Algebra 2, Lesson 5.5, Dilating Functions. So dilation is a fancy way to say stretch. And we're going to do that using multiplication. And multiplication and division are opposites, so technically you can multiply or divide, and I'll talk about that in a second. But all the same stuff from before still applies. We can still add and subtract to translate or slide. We can still utilize negatives to reflect or flip. And now we're also going to utilize multiplication to stretch or shrink, depending on if we are multiplying by what number or dividing by what number. That number, I'm going to use the letter A. It's kind of like slope, so it's rise over run, but I'm going to say how that works in each case. So I like to think about it if we printed these graphs on a balloon. You know those balloons that say happy birthday on them and you can blow them up and then the text gets bigger? So if you had one of these graphs printed on the balloon and you pulled it this way, your graph would get taller, but at the same time it would get a little skinnier. That's a vertical dilation. Whereas if you pulled it sideways, it would get wider, but at the same time it would get a little bit shorter. That's what we call a horizontal dilation. And so when we multiply our function by a value larger than 1, it's going to stretch it taller and at the same time get a little bit skinnier. Whereas if we were to multiply our function by a value less than 1, so a decimal, 0.5, half, 0.75, it would get wider and shorter. Now I said you can also technically divide these. If you were going to divide by a number instead, what you would notice happen is if you are dividing by a decimal, it would do the same thing as multiplying by a larger number. And so what I mean is if you multiply by 2, it's the same as dividing by a half. Versus on this one, if we were going to divide by a number, it's going to be if your number is bigger than 1. And I think this one makes more sense because if I was going to multiply by a half, that's the same as dividing it by 2. I'm not going to give you a lot of divides. I just wanted to put it out there. We're going to focus primarily on multiplying. So multiplying by 2, 3, 4, 5, anything bigger than 1 is going to stretch it tall. And multiplying by decimals or fractions, like a half, a quarter, is going to stretch it wide. So, letter A, I see 3 things happening. On my function g of x, 2 times the absolute value of x plus 2 minus 5. The times 2 in the front is a vertical dilation. Because that number is bigger than 1, it's going to stretch my absolute value graph taller. So I'm going to use the technical vertical dilate. You can also just say stretch tall. It means the same thing. That's the new piece from this page, but I also have a couple of review pieces. I see a plus 2 inside, and I see a minus 5 outside. I'm going to be less technical on those. A left 2 from the plus 2, right? A plus inside is a left and right. Right is minus, left is plus. And a minus outside, any number outside is an up and down. Because it's a minus, it is a down. So we slide left 2, we slide down 5. Letter B, let f of x equal x. So I'm talking about a linear function in this case. Write an equation for a vertical dilation factor 4th and translation up 3 units. So with this vertical dilation factor of 4th, that means I can multiply by a 4th or I can divide by 4. Either way, that's going to be a horizontal. That's going to be it's going to be a stretch wide. in a shrink tall. So that would be y equals a fourth. That's going to make it get shorter, but wider at the same time. Ooh, I'm not doing absolute value. I'm doing a linear equation. So I want a parentheses, not a bar. And then that will be x. And it says up 3. So I don't need a plus or minus inside. It doesn't slide at all. So now I need a plus 3 to slide it up 3. And my graph then would be up 3. And my slope is 1/4. So a regular linear equation should kind of go up at a 45-degree angle. Because I have a slope of 1/4, I'm going to go up 1/4. Try to eyeball that. And so my slope is actually going to cause my line to stretch wide. It gets shorter and wider at the same time based off of a normal one at that pretty regular 45-degree angle. And the last one. Letter C. Write an equation for the graph at right. I see a U-shaped graph. So I know I am working with a parabola, a quadratic, an x squared. It is a little skinnier than a standard parent function quadratic. So I'm going to need something in front to make it a little skinnier. And then I'm going to need something here to slide it to the side. I'm going to need something here to slide it vertically. But I need that power 2 because it is a U-shaped graph. So I said that number in front is kind of like rise over run, kind of like slope. So from the vertex, I can try to follow this graph and count how many up, how many over. But that doesn't really work too well. If I count 1 up and that's like 0.6, 0.7, 0.89 over, I'm not really sure. So I'm going to instead follow the graph until I get to something I can easily count. So I don't want to stop here. I don't want to stop here. This is my winner. That's my point that falls right on the grid line so that I can actually count. So I can count how many up and how many over to calculate that A value. So that's up 1, 2, 3, 4, 5, 6. And it's over 2. So that means my dilation factor is 3. This is 3 times taller than a standard parabola. Next, I need my horizontal translation. So now we're looking from origin to vertex. And we talked about this in lesson 5.3. My origin is here. To get to the vertex here, I need to move 1, 2, 3, 4 spaces to the left. And 1, 2 spaces up. So moving to the left is inside. A left is a plus. We're moving in the negative direction, so minus a negative is a plus, and that is a 4 to the left. And then we're also moving up 2, so I need a plus 2 at the back. That is the last bit of notes for this packet. Good luck on these exercises, and let me know when you are ready for your test.